In part 1 of our first presentation, we introduced a mystical tradition that claims that the secrets of creation are contained within the first passage of Genesis. We also introduced a second mystical tradition which is revealed through ancient texts such as the Sefer Yetzirah, and claims that the process of creation unfolded through the mystical properties of the Hebrew letters. We then combined these two concepts with a third mystical tradition that claims that the original letters of Mount Sinai revelation were geometric and spherical in nature. We then proposed a geometric letter system based on the modern Hebrew letters. When these letters are converted into their geometric symbols and inserted into the Genesis words and passages, they generate meaningful and scientific patterns. In this slide, for example, we inserted the geometric symbols into Hebrew words associated with the creation story of Genesis. The simple pictographic patterns that result are consistent with the fire, air, water cosmological model presented in the Sefer Yetzirah. We must first consider an important question. Are these pictographic patterns and the geometric letters that produce them really the intent of the author of the Sefer Yetzirah, or are they the result of my overactive imagination? Are these so-called mystically derived patterns intelligently designed constructions, or are they the result of a cognitive bias that seeks to find patterns where no truly designed patterns exist? If after viewing the evidence described in the first part of this presentation, you are left with a strong impression that these patterns are real, then you are immediately confronted with the second question. Because if the described patterns are real, we must then ask, are these mathematical patterns the result of divine revelation, or are they the result of rabbinic fabrication? If you are viewing this slide, I can assume that for the moment at least, you are still curious, and that you have not discounted the possibility that these patterns are real. In this slide, we earlier described how the word avir, which does not appear in the Genesis passage, becomes an air, wind, on earth metaphor for the light on curved space model that is constructed from the words Yehi Or. Yehi Or, let there be light, is a phrase that does indeed appear in the first passage of Genesis. The phrase Yehi Or consists of 5 different letters: Yud, He, Aleph, Vav, and Resh. We can separate these letters into 2 groups. The Yud, Vav, and He, which we described in part 1 of the introduction, are the letters of God's great name, the Tetragrammaton, and were used to construct the heaven or Shamayim sphere. The remaining 2 letters, the Resh and the Aleph, obey the algorithmic structure provided by the first 3 letters of the Genesis text. The first 3 letters of the first word of Genesis, Bereshit, in the beginning, are the letters Beit, Resh, Aleph. Beit has the numerical value of 2, and when combined with the Resh and Aleph, direct us to take Beit, or 2 Resh geodesic curves, and intersect them to form the Aleph origin coordinate location on the surface of a generic sphere. But the Beit itself consists of a Resh geodesic on a rotational axis. And when spun around on this axis, like the letter whirlwinds described in the Sefer Yetzirah, they form the spherical constructs on which the geometric letters will be embedded. The mystical tradition says there are creation secrets buried in the text. And the mystical tradition says that the letters are the foundation on which creation was organized. Now, with the Hebrew letters revealing their geometric properties, we can see the Genesis text beginning to unfold into a series of scientific and mathematical statements. As we mentioned earlier, the Yud, Vav, He are the letters of God's great name. And as we mentioned earlier, the letters coalesce into the heavenly sphere, with man the observer at the center of this vast cosmic system. This cosmic sphere extends out into the 6 directions of 3-dimensional space and is represented by the letters and geometry of God's great name as described in this passage from the Sefer Yetzirah. And here we lay out the 3 Yud Vav He letters into the 4-letter Tetragrammaton name of God. As we described in part 1 of the introduction, the name depicts the Yud flame, the He wavefront, and the Vav vector. But as we described earlier, there is a second He wavefront. The Tetragrammaton does not appear in the first passage of Genesis, but the Elohim name of God appears 6 times. We can now surmise that the Tetragrammaton name, with 1 Vav and 2 He symbols, represents a unity of 2 possible orientations of the Elohim name, thereby constructing 1 double Lamed wave structure corresponding to the 1 Vav vector symbol. The Elohim construction on top depicts the Lamed electric oscillation perpendicular to the horizontal Hayam ocean or He Yud Mem Sofit planar surface. And the Elohim construction below depicts a second Lamed magnetic oscillation perpendicular to a second He Yud Mem Sofit plane. But this planar surface extends into the depths above and below the horizontal Mayim or metaphorical water surface. The 2 Lamed wave oscillations correspond to 2 He wavefronts advancing over 2 planar surfaces. These 2 planar surfaces are represented in the Genesis text as the metaphorical water or Hamayim plane and its perpendicular metaphorical depth or Tehom plane. So the electric Lamed oscillation has a wave displacement perpendicular to the Mayim or water plane, but itself is embedded in the Tehom or depth plane. Here we depict the letter-by-letter construction of the Tehom and the Hamayim geometric letter symbols. The Lamed electric oscillation is perpendicular to the Hamayim surface, but is completely embedded in the Tehom surface. The Tehom construction, which indicates that the double Lamed construction represented as the Vav light ray vector, can be rotated off the Hamayim plane, and later we will describe how the wave amplitude diminishes as the vector rotates off its horizontal plane until it stands upright in the dark or Choshech conformation. And here we depict the second Lamed or magnetic oscillation, which is perpendicular to the electric Lamed oscillation embedded in the Tehom plane. This magnetic oscillation, whose wave displacement is perpendicular to the vertical depth or Tehom plane, is embedded on the horizontal water or Hamayim surface. I must emphasize that the words Tehom and Hamayim are poetic or metaphorical representations of mathematical and geometric constructions that are revealed by a deeper analysis of the word's Hebrew letter geometry. This poetic or metaphorical transformation into deeper geometric and scientific content will be further illustrated in later presentations. For example, we will later demonstrate that the electric Lamed oscillation embedded on the face of the deep, or Alpanei Tehom, causes a circulating magnetic wind depicted by the statement Baruch Elokim Merachefet, which in turn generates the Lamed magnetic wave oscillation embedded on the face of the waters, Alpanei Hamayim. But more on this elegant construction later. Meanwhile, let us return to the Yehi Or construction, because it highlighted a very important observation. If you remember from part 1 of the introduction, the Mem, Aleph, and Shin letters were the mystical representation of Mayim water, Ruach wind, and Eish fire. The Aleph represented Ruach, or wind, from which Avir air is established. We now know that the Ruach is probably a metaphorical representation of some property associated with light. But the Avir, which translates as air, does not appear in the Genesis text, and we concluded that the Avir air is probably the metaphorical representation of the Yehi Or construction, which does indeed appear in the Genesis text, and which propels us to an important assumption. We must assume that underneath the metaphorical heaven-earth prosaic cipher text, the geometric plain text translation is describing a higher dimensional curved space and a higher dimensional curved space-time spherical model. Like the Ruach wind and Avir air that flows over the smoothly curved spherical surface of the earth-water metaphor, the light of Yehi Or flows over the idealized, smoothly curved spherical surface of space and space-time. The concept of curved space would seem to be a rather advanced and anachronistic concept to find in an ancient document, but I must point out that references to such a finite, unbounded model of the universe are found in the works of Lucretius, a first-century Roman poet, in his epic poem De Rerum Natura. Through the passages of the Sefer Yetzirah, we assembled our dome on sphere, or heaven and earth metaphorical sphere model. But we now are beginning to realize that the heaven and earth metaphor is too simplistic to sequentially embed all the letters of the first Genesis passage into a consistent and scientifically meaningful description of creation. It will take spherical models of higher dimensions, in which three-dimensional space is curved into a four-dimensional spatial hypersphere, and four-dimensional space-time is curved into a five-dimensional space-time force-sphere, to successfully generate a consistent plain-text translation of all 197 letters of the Day 1 passage of Genesis. And as described earlier, we are the observers in the center of a vast cosmic sphere with incoming light and information that has traveled through 15 billion years of cosmic history from the dark ages of the cosmic beginnings. This spherical space, which extends out in the 6 directions described by the Sefer Yetzirah, and which is mystically represented by the geometric construction of the 4-letter tetragrammaton, is encompassed by the Have wavefront that represents the outgoing information limit or event horizon that circumscribes our bubble of accessible knowledge. And this spherical cosmic bubble, illustrated on top, which represents our observable universe, is probably only one tiny small spherical region embedded in the surface of a far more vast spherically curved space described as the metaverse, or level 1 multiverse. Keeping this higher dimensional model in mind, we will now begin to extract the scientific content from the Genesis text. And now, as we here return to the first 5 letters of the Genesis text, we now know that the simple heaven dome on earth globe model will not be sufficient to embed all the letters of the Day 1 creation passage. Models of higher dimensions will be required. In this slide, we illustrate a larger sphere with a curved x-axis and a curved z-axis. These two Reish geodesics curve into a third dimension. In the case of the Earth globe, that third dimension is simply the y spatial axis. But for spheres of higher dimension, that third dimensional axis extends through a higher unseen dimension. We call this axis the imaginary space axis and label it S sub I. The I refers to the imaginary number I, which is the square root of -1. The imaginary space axis is constructed by multiplying the real ordinate numbers on this coordinate axis by I. For the next group of slides that describe the relationship of time, space, and light in the special theory of relativity, both models work well, and both meaningfully embed the Genesis letter sequences into a mathematical and physically consistent pattern. In this slide, 2 Reish geodesic curves intersect and construct the Aleph coordinate location on the sphere surface. The Shin 3-dimensional space is positioned at the Aleph coordinate location, and in the case of the Earth globe model, rests on the sphere surface, where they share the same y-axis. In the case of the higher dimensional sphere, the Shin space of the heaven dome component is completely embedded within the surface of this higher dimensional sphere at the Aleph location. But since we are unable to graphically represent and mentally visualize structures extending into 4 dimensions. The larger 4-dimensional sphere is represented without its extension into the y-axis. Later, we will describe various methods to more fully represent these higher dimensional structures. Notice the Yud particle and its path through the 3-dimensional Shin space. Since it occupies a position that has x, z, as well as y coordinate components, it cannot be plotted on the curved xz planar surface. And here we illustrate the double wavefront construction rotated upward into the heaven Hashamayim plane. This assembly of letters depicts on the bottom 2 raised geodesics curving over the globe and intersecting at the aleph from where the double wave originates. The double lamed wave can be rotated and oriented anywhere within the 3-dimensional Shin space of the Hashamayim heavens, depicted here as the celestial dome. Here we illustrated all 14 letters from the first phrase of Genesis, Bereshit bara Elokim, in the beginning God created. Using the geometric letter system that I proposed, and which is based on the clues provided by the Sefer Yetzirah, we are beginning to see that the poetic Genesis passage has a deeper mathematical structure. Take special note of the letter Shin, which appears in the 2 middle dome structures of the top row of double sphere figures. As we described earlier, it represents the 3-dimensional spatial reference system, and in the first figure combines with the letter Aleph to form the word Eish, or fire, and in the next figure combines with the Yud light particle to represent a point-like coordinate position in 3-dimensional space. But the Shin spatial reference system need not remain fixed in one position, because if we consider the relative motion of one spatial reference frame in relation to another, then we introduce the concept of a moving Shin. In this diagram, which comes from Albert Einstein's book on relativity from 1922, we can see the relative motion of a Shin-like spatial reference frame labeled x prime, y prime, z prime, moving inertially in relation to a second fixed spatial reference frame labeled x, y, z. But it is important to note that the Shin prime frame could have been chosen as the fixed frame, and the other Shin the moving reference frame. When considering relative motion, there are no mathematically preferred frames of reference. But more important, we will soon see that when we consider the properties of light, there are also no physically preferred frames of reference. And in this slide, with the Shin space reference symbol moved to a new Aleph surface position in relation to the fixed Aleph origin, and also a new position in relation to the advancing Yud light particle, we can now easily identify the Pythagorean right triangle constructed from the fixed Aleph, moving Shin, and Yud particle configuration. Using our geometric letter notation system embedded in the celestial dome component of our double sphere model, we demonstrated that the Aleph Shin Yud assembly precisely defines the components of the light clock experiment. The light clock experiment mathematically defines the relationship of space, time, and light propagation in frames of reference moving at different inertial speeds in relation to each other. The mathematical structure of the light clock experiment takes the form of a Pythagorean right triangle. Here we lay out the 3 line segments that form the Pythagorean right triangle. In high school geometry, the vertex points that are used to name the line segments are generally arbitrary letter symbols such as A, B, and C. But here the vertex points and line segments are named from geometric symbols that are meaningful descriptors for the physical process that is unfolding on the page. We can see that the fixed Aleph, moving Shin, and advancing Yud light particle make the vertex points for this Pythagorean right triangle. The line segment constructed from the fixed Aleph to the moving Shin represents the distance or space traveled by the moving Shin and is equal to the Shin velocity multiplied by its travel time. the line segment constructed from the moving shin to the Yud particle moving up the light clock is the distance the light traveled in the moving shin frame of reference, and the distance is equal to the speed of light multiplied by its travel time as measured by the moving shin observer. The line segment from the fixed aleph to the Yud light particle is the distance the Yud has traveled in relation to the fixed reference frame at aleph, and is equal to the speed of light multiplied by the time measured by the observer at the fixed aleph location. But since the aleph Yud hypotenuse is clearly a different length than the shin Yud segment, we must conclude that the two reference frames, one at shin and the other at aleph, either measure different velocities for the speed of light, or, if the speed of light is indeed a universal constant, must experience the passage of time differently, shattering the prior Newtonian concept of absolute space and absolute time. The Michelson-Morley experiment was designed to confirm the prevailing theory of the late 19th century, that the speed of light is fixed in the ether of space, and that different bodies moving at different relative speeds within this ether, such as the Earth, would measure different speeds for the velocity of light. The experiment was, however, a great disappointment to most physicists of that generation, since the experiment, and many others since then, clearly demonstrated that regardless of the relative velocity of a frame of reference, the velocity of light in a vacuum would always be exactly the same. The implications of this famous experiment leads to some counterintuitive implications. Our moving observer, represented by the moving shin, and our fixed observer, represented by the stationary aleph, indeed measure different travel distances for the Yud light particle. But the difference in distances measured is not the result of different relative velocities for the speed of light. The moving and stationary frames of reference indeed observe that the speed of light is an invariant property of nature, and when measured in a vacuum, this speed is universally constant. It is the passage of time that changes from one frame of reference to another moving at some constant inertial speed relative to the first fixed frame. And any inertial frame could in fact consider itself the fixed frame when doing the mathematical analysis of some physical experiment. But the universe and all the physical phenomena that occur within remain objectively covariant. That is, the results of experiments conducted in one moving frame can be translated into the data collected in another frame by applying a simple set of translational rules known as the Lorentz transformation. These translational rules are here illustrated with the time dilation experiment and its time dilation equation, which is an algebraic expression of the statement constructed by the first 14 letters of the Genesis text. In the beginning, God constructed the covariance principle, which interconnects all observers in time and space into one objective and self-consistent universe. The first 14 letters of the Genesis text, Breshit bara Elokim, are here laid out in 6 panels. On the top we depict the 3 vertex points, the Aleph, Shin, and Yud, that define the 2 short arms of the right triangle generated by the light clock experiment. On the bottom we illustrate the 2 vertex points, the Aleph and the Yud, that are bridged by the Lamed wave, and which define the hypotenuse of this right triangle. The hypotenuse represents the radius of the light sphere observed from the fixed Aleph origin. The position of the Yud pulse of light on this spherical Hay wavefront will be determined by the rectangular and polar coordinate values obtained from the light ray constructed on the vertical and horizontal plane sections through this sphere. The 3 line segments of the right triangle are here illustrated along with the numerical base exponent symbols in the appropriate locations to complete the Pythagorean theorem. Since we are not restricted by any algebraic convention, the exponent symbols can appear before or after the line segment term. So what do we have? Well, it doesn't take much imagination to see that the Resh Aleph to Shin segment squared plus the Shin to Yud Tav segment squared is equal to the Resh Aleph to the Hey Yud segment squared. Later we will see that when we replace the Aleph Shin segment with V times T, the Shin Yud segment with C times T prime, and the Aleph Yud segment with C times T, we get the square of V times T plus the square of C times T prime is equal to the square of C times T. And with some simple algebra, we get T prime is equal to T times the square root of 1 minus V squared over C squared, the time dilation equation for the Lorentz transform. This equation provides the mathematical tools for translating the observational measurements from one inertially moving frame of reference into another. All this will be explained in greater detail in the next presentation. For now, just note that the Aleph, Shin, and Yud form the vertex points for a right triangle, and that the letter symbols in the first 14 letters of Genesis describe and define this triangle and organize into the Pythagorean theorem. Bereshit bara Elokim. In the beginning, God created. When the letters of this passage are converted into their geometric and numeric symbols, a geometric pattern is created that is readily recognized as the structure of a right triangle that conveys the content of the Pythagorean theorem. But in this case, the theorem is specified for a physical system that includes light particles, wave fronts, and moving spatial coordinate frames. This interpretation is further corroborated by the next 4 words of the passage, Et Hashamayim ve'et ha'aretz, which define and describe 2 planes associated with this physically relevant right triangle. The 2 planes are the vertical heaven or Shamayim plane and the horizontal Aretz or earth plane. And within these 2 planes, the Vav ray vector has an orientation that is defined within the 2 Aleph coordinate grids. Within these Aleph grids, the rectangular and polar coordinate information is provided by the geometry of the Tav symbol, and the Tav geometry is in turn bounded by the spherical Hey wavefront. Et Hashamayim translates the heavens, and here we can see that the geometry defines the Yud point particle in relation to a vector rotated into the vertical plane relative to the spatial reference frame fixed at the Aleph origin. And here we have the Et Haaretz, which translates and the earth, and refers to the earth's surface plane. The geometry here describes the rotation of the vector along the horizontal earth-water plane. Up until now, we have used the Tav and the Hey to define rectangular and polar coordinate positions on a spherical wavefront, as we just illustrated in the algorithmic structure of the words Et Hashamayim ve'et ha'aretz. But as we move our analysis from a 3-dimensional sphere-on-sphere model to models of space and space-time in higher dimensions, it will be necessary to redefine the Tav and Hey symbols. The analysis resulting from this modification will produce a series of equations and algorithms that are topologically consistent and meaningful throughout the first passage of Genesis text. For example, here we illustrate the relation of the Tav and the Hey to the metaphorical Mayim or water sphere. Earlier we described how the Beit Resh Aleph construction generates 2 perpendicular great circle Resh arcs intersecting at the Aleph origin. Now, by constructing any arbitrary Tav symbol on the Resh curve and rotating it over the Mayim surface parallel to the second perpendicular Resh curve, an arbitrarily dense series of pseudo-parallel Hey arcs can be constructed. And when this procedure is repeated with the other perpendicular Resh geodesic, an arbitrarily dense curved non-Cartesian grid system is constructed. The resulting grid system is an example of a Gaussian coordinate system for smoothly curved surfaces, but is here specific for the special case of a sphere. The process of constructing a Gaussian coordinate system on a spherical surface is illustrated with the next 3 slides that depict the Genesis statement for Haaretz Hayta Tohu Vavohu, and the earth was without form and void. In these 4 sphere panels, we depict the 5 letters of Haaretz, translated, and the earth. The word consists of the Vav, He, Aleph, Resh, and Tzadi Sofit. It is important to remember that the algorithm is constructed on a spherical surface, but the sphere is not necessarily a 3-dimensional sphere like the Earth globe. Instead, it could be a section from a hypersphere, with 2 spatial Resh geodesics curved into an imaginary space axis. Or it can also be a spherically curved space-time sphere, with the Resh space geodesic and a Resh time geodesic. These 2 Resh curves define a surface that is also curved into the imaginary space axis. We will demonstrate that multiple topologically consistent and meaningful algorithmic statements can be constructed on at least 3-dimensional levels. In this construction, we depict a Vav vector, which begins at the point where the He arcs intersect at the Aleph position, and this vector moves over some Resh geodesic path at some arbitrary Tzadi Sofit run path angle. In the next 4 letters of the sequence, the He symbols are doubled to create 2 perpendicular coordinate arcs that intersect at the Yud point. The construction of the He arcs are then described by the next 4 letters, here showing the Tav rotating over the sphere surface to construct 1 He coordinate arc. And in the next slide, we here show the 4 letters in sequence, Tav He, constructing the 2 He arcs which run pseudo-parallel to the Resh geodesics that meet at Aleph. These intersecting He arcs define a precise location on a Gaussian coordinate grid with its coordinate axis origin at Aleph. And we now illustrate the last 5 letters of this letter sequence, Vav Vav, Beit He Vav. With these final 5 letters illustrated in the last 2 panels, 2 Vav Re components provide the distance segments from the He Aleph position to the He arcs passing through the Yud point. And in the final panel, the Beit He, or 2 spherical He arcs, which intersect at the Yud point, determine the orientation of a 3rd Vav Re, which represents the distance from the original He Aleph position to the He Yud point. The entire sequence of letters represented here can be treated as an algorithmic loop, and a next He Aleph can now be reset at the previous He Yud, and the process repeated to construct a path over the spherical surface. By repeating the process with smaller and smaller He increments, we can approximate a smoothly curved path over the spherical surface. And by applying the principles of calculus to integrate the distance by summing all the components as the increments become infinitesimally small and approach 0 length, we can then obtain an exact measure of the distance between any 2 points on a smoothly curved surface. Later we will demonstrate that by applying a variation of the Pythagorean theorem for right triangles, and by applying the Gaussian coordinate construction that was just described, we can generate the metrical ground form analysis for a spherical surface of arbitrary radius. The metrical ground form is a measure of surface curvature, and therefore is the pathway to the general theory of relativity, which models gravitation as space-time curvature. We started with 22 letters in a circle, like a wall with 231 gates. From this clue in the Sapiensira, we constructed the dome model. With additional clues provided by the Sapiensira, we expanded our model to the heaven dome on Earth globe system in which our geometric letter symbols embed to reveal the deeper mathematical structure in the words of the first Genesis passage. But now we are beginning to see that this heaven and earth model is only a simple metaphor, and that a complete geometric translation of the first Genesis passage will require a model that extends into higher dimensions of space and time. But where are the clues that the geometric model generated by the Sapiensira extends beyond the simple heaven dome on earth globe model into structures consisting of 4 and 5 dimensions? And where is the evidence that the Genesis text translates into deeper mathematical patterns that embed into higher dimensional space and space-time models? The Sapiensira makes several references to a model constructed in 5 dimensions. Here the passage describes that the Mem, Aleph, and Shin mother letters are constructed within a system that consists of 3 components. The universe or world refers to the 3 dimensions of space. The year refers to time. And the soul refers to the higher dimension, which in the case of the proposed model is the dimension of space-time curvature. In another passage, the reference to a system of 5 dimensions or 10 measures is even clearer, and in this slide we present the Sapiensira passage on the left and compare it on the right to the description of curved space-time provided in Rudy Rucker's book, The Fourth Dimension. Both the Sapiensira and Rudy Rucker refer to 1 dimension of time, 3 dimensions of space, and an additional dimension which in Rudy Rucker's colorful description can be described as a dimension of soul. Rudy Rucker writes, "We might think of heaven as lying above our space, and hell as lying below. A 4-dimensional angel expelled from heaven would tumble through our space like a man falling through flatland." And if we consider the Hebrew word for day, Yom, spelled Yud Vav Mem Sofit, we see that a geometric translation provides a compact algorithm for the construction of a unit of space-time. The Yud represents a 0-dimensional point. The Vav represents a 1-dimensional ray. The Mem Sofit represents a 2-dimensional plane. From the Yud we depict 6 or Vav arrows pointing in 6 directions and intersecting with 6 or Vav Mem Sofit planes, providing an efficient description for a 3-dimensional cube. And finally, the bottom left figure represents a Yud point with 6 or Vav mutually perpendicular planar surfaces intersecting at that point to describe the 6 planar surfaces that define the metric analysis for the curvature of space-time. And here we illustrate the 4-dimensional block or hypercube of space-time embedded in the surface of a spherically curved 5-dimensional sphere with a 4-dimensional space-time surface. The Yom, or Yud Vav Mem Sofit construction, here depicts a 2-dimensional section of space-time. And here we depict the mysterious 4-pronged shin on the tefillin box that Orthodox Jews wear during the daily prayers every weekday morning. The 4-dimensional shin is engraved on the tefillin box which is placed on the head, or rosh, spelled Resh Aleph Shin, and as you can see, is essentially the model for a local block of space-time embedded on the 4-dimensional surface of a 5-dimensional sphere. But before we begin to deconstruct and analyze the spherical 5-dimensional space-time model, we must take one step down the dimensional ladder and consider 2 important 4-dimensional geometric structures: the 4-dimensional spatial hypersphere and the 4-dimensional space-time manifold. The spatial hypersphere is a 4-dimensional sphere in which a 3-dimensional spatial surface is curved into an unseen higher dimension which we labeled S sub I for the imaginary spatial axis. The mathematical nomenclature or name for this hypersphere is a three-sphere because it has a three-dimensional surface. It is often easier to understand higher dimensional geometry by thinking of analogous structures in lower dimensions. For example, the Earth globe or a beach ball are good examples of a three-dimensional two-sphere that has a three-dimensional structure but a two-dimensional spherically curved surface. In contrast to the easily perceived two-sphere, the four-dimensional three-sphere cannot be visualized in our primate brain. We simply do not have the brain wiring to cognitively construct these mental images. There are, however, some mathematical and graphic tricks that can be applied to better understand these higher dimensional forms. Let us first consider how we might graphically depict geometric structures of higher dimension by using an analogy from a related geometric structure of a lower dimension. Here, for example, the standard three-dimensional two-sphere on the left is crushed into a two-dimensional plane on the right to depict how a flatlander living in a two-dimensional world might envision the three-dimensional sphere. And here is how a four-dimensional hypersphere with a local spherical space embedded in its curved surface may be partially depicted crushed into a three-dimensional volume. Here only two of the higher four-dimensional sphere's three-dimensional sections are represented in the diagram. You will notice that when you crush an n-dimensional sphere into an n-1 dimensional volume, the axis of curvature will seem to point out in every possible direction within the n-1 dimensional space. But when you lift the crushed structure back into its higher dimensional realm, all these axes converge into the one true axis. By taking lower dimensional cuts or sections through our higher dimensional structure, we can illustrate important components of the higher dimensional form. Here we illustrate above a three-dimensional sphere, which is embedded in the surface of the four-dimensional hypersphere below. The three-dimensional sphere can represent a three-dimensional sphere of light advancing through the curved three-dimensional space of the meta-universe surface. Or the sphere can also represent the outer limit of incoming light and information from the beginning epochs of cosmic creation, in which case it represents the event horizon for our observable universe. In any case, the illustrated hypersphere below can only depict two of the three curved spatial axes of three-dimensional space. In this case, the two axes are the x and z axes that are curved into the imaginary space axis. The x and z axes define a planar region that is relatively flat and two-dimensional in a small region near the origin. This small flat local region is called a manifold. Also note another curved raised geodesic that is labeled S for space that runs in the same curved planar surface defined by the x and z raised curves. In order to visualize the curved y-axis, it will be necessary to take a different three-dimensional section through the hypersphere, a section that in a four-dimensional space is perpendicular to the first section. In this slide, we now illustrate a perpendicular manifold constructed on a spherical surface in which the y-raised geodesic and the s-raised geodesic intersect at the Aleph origin. Whereas the xz manifold depicted in the previous slide could be metaphorically described as a horizontal Mayim water plane, this vertical plane would be metaphorically described as the Tehom depth or Shamayim heaven plane. The horizontal Mayim and vertical Tehom planes are perpendicular to each other and displayed in the light sphere depicted in the upper right portion of the slide. The vertical Tehom or depth plane presented in the previous slide is here displayed again, but now instead of depicting the Tehom depth manifold within the light sphere, we now depict the vertical Tehom manifold in relation to the four-dimensional block of spacetime. A small region of spacetime, though globally curved into a five-dimensional sphere, will be locally flat near the coordinate origin. This relatively flat hypervolume of space and time is a four-manifold and is labeled 3s1t for its 3 dimensions of space and 1 dimension of time. And in this higher dimensional sphere, we add the dimension of time and illustrate a spherical section of space and time. The space-time manifold is here displayed in relation to the space-time sphere, as well as being displayed as a cut through a light cone above and as a cut through a block of space-time on the right. The 6 slides that we have just viewed will be the geometric embedding model on which 197 letters of the first Genesis passage will embed. All the algorithmic sequences and mathematical equations generated by a sequential geometric translation of the Genesis passage will fit together on the interlocking pieces of this geometric Genesis puzzle. In the previous slides, the 5-dimensional space-time sphere was deconstructed into multiple lower dimensional sections. Now we have the geometric architecture in multiple sections of space and time to embed the light clock experiment which we introduced earlier in this presentation. Here, embedded in the vertical to home section, we can now visualize the right triangle of the light clock experiment in relation to its orientation in curved space. And here, in a spherical space-time section, we illustrate another right triangle. In this case, the right triangle is constructed in space and time and represents the light clock experiment as it unfolds in time. In the diagram to the right of the space-time sphere, the right triangles that depict the geometry of the light clock experiment are presented in the 3-dimensional space of the light sphere, as well as in the 4-dimensional space-time of the light cone. In a few moments, the relationship of these triangles will be more clearly explained. But for now, remember that these triangles are embedded in the curved surfaces of higher dimensional spheres of space and embedded in the curved surfaces of higher dimensional spheres of space and time. Now, anyone with a background in mathematics will argue that constructing right triangles on spherical surfaces, as we repeatedly do here, is problematic because the Pythagorean theorem only applies to right triangles constructed on flat Euclidean surfaces. But this argument is no obstacle, and in fact, it is an opportunity, for it highlights a very important principle that allows us to interpret the geometric structure of the text along 2 very different geometric paradigms. The Pythagorean theorem becomes true in 2 situations in which triangles are constructed on spherical surfaces. The first paradigm will be applied to the formulation of special relativity. In this case, the constructed triangle is of finite measurements, but it is constructed on a sphere whose radius approaches infinite length. On such an infinitely large sphere, the space and space-time surfaces become flat, or in other words, have minimal curvature. In such a case, right triangles will approximate flat Euclidean right triangles, and the Pythagorean theorem will be applicable. The second paradigm, in which the Pythagorean theorem can be applied to a spherical surface, is used to model the space-time curvature of general relativity, and it makes the opposite assumptions. In this case, the sphere is of some definite finite radius, but the triangle that is constructed on its curved spherical space and space-time surfaces is allowed to shrink to infinitesimal smallness. As this curved manifold region in which the triangle is embedded gets smaller and smaller, the embedded triangle experiences less and less surface curvature and mathematically approaches the Euclidean right triangle that obeys the Pythagorean theorem. By applying this analysis to a local grid region of a sphere surface, we generate the metrical ground form, which we will discuss in our third presentation. For now, we will briefly focus on a right triangle constructed on a spherical space-time surface that approaches infinite radius. and we will once again focus on the Aleph, Shin, and Yud vertex points that we described earlier. In this first case, the five-dimensional space-time sphere has a radius that approaches infinite length. The resulting space-time surface is therefore essentially flat, and we can now ignore the imaginary space axis and focus on the four other dimensional axes, the three space axes and the fourth dimensional time axis. On the bottom of this slide, we highlight a block of space-time, which is constructed with the x and z spatial axes and a vertical time axis. Above, we show a three-dimensional light sphere with the horizontal x and z axes and the vertical y axis. Together, the block of space-time and the light sphere above represent the same light clock experiment we illustrated earlier with our little running man. In this diagram, the Starship Enterprise is moving inertially, that is, at constant speed, through space and time as it approaches the space station at the fixed and stationary Aleph origin. As it passes the space station, the Enterprise fires a photon torpedo along its y-axis. Above this block of space-time, the topmost and latest section of space-time is represented with the three-dimensional light sphere that now includes the sphere's extension into the y-axis dimension. Within this light sphere, we diagram a right triangle with the space station, the Enterprise, and the photon torpedo forming the vertex points for this triangle. But there is another right triangle constructed within this block of space-time, and in a moment we will focus on that space-time triangle and how it is related to the top triangle, which is constructed within 3 dimensions of space. But first, we will illustrate the light cone and its relationship to the light sphere. At the Yud point-like flash or flame, a light sphere begins to grow and propagate through space in 3 dimensions. But since we are using 1 dimension to depict time, we represent our growing light sphere as an expanding circle constructing a cone through time. This is the light cone, and in this case it expands over time, representing outgoing light and outgoing information, so it is called a future light cone. Since nothing travels faster than the speed of light, the light cone represents a boundary for outgoing information. The path of an object through space and time is called its world line, and this world line must always run within the boundaries of the light cone. In the top diagram, the spatial cut through the light cone is represented in 3 dimensions, and the position of the photon on the surface of the light sphere means that it is also on the surface of the 4-dimensional light cone. And now we can see that as the space station and Starship Enterprise make a right triangle with the photon torpedo in 3-dimensional space, they also form what appears to be another right triangle with the original Yud flash point in 4 dimensions of space-time. The mathematics that describes the construction of this triangle in 4 dimensions of space-time is called Minkowskian geometry. The interesting feature of this right triangle is that when you set up the equation to solve for the hypotenuse, which represents time experienced by the inertially moving starship, it takes the following form. The square of ct prime is equal to the square of ct minus the square of v times t, where t prime is the starship's proper time. This will all be explained in the next presentation, but for now it is sufficient to recognize that space and time form a unified continuum, and that by multiplying the time values by the universally constant speed of light, which is c, we create a unification between space and time that provides an efficient mathematical way to plot events and phenomena that occur in space and time. Since the speed of light remains constant in moving reference frames, the proper time experienced by the moving inertial frame relative to the stationary reference is dilated, or in other words, the clock ticks slower and less time passes. Consequently, when the Pythagorean theorem is applied, a minus sign shows up before the square of the space or distance terms. This is called a negative metric signature, in contrast to the positive metric we see in the geometry of three-dimensional space, where no negative sign shows up in the Pythagorean right triangle. And here we transition to a space-time section highlighting the right triangle of Minkowskian spacetime geometry. And in the upper right portion of the slide, we again show how the spacetime right triangle locks together with the spatial right triangle of the light clock experiment. In this slide, we rotate the SY plane so it is graphically represented perpendicular to the time axis, demonstrating here how the two triangles lock together in a block of spacetime where we represent the one dimension of time with only two dimensions of space. Notice on the left how the two line segments from the Beit Resh Aleph position to the two positions defined by the Aleph Lamed Hey Yud Mem construction complete the triangles on the right, and when rotated around 360 degrees traces the boundary of the light cone. The equations are laid out in the upper left, and the first 14 letters of Genesis appear to precisely define the geometric structure of special relativity in both the standard Euclidean geometry of space as well as in the Minkowskian geometry of space-time. In three-dimensional space, the calculation of distance using the Pythagorean equation is illustrated in the diagram on the left and has the familiar form of an equation with a positive metric. But on the right we notice that to calculate the hypotenuse length in four-dimensional space-time, the spatial distance terms have a negative sign. As we mentioned earlier, the hypotenuse in four-dimensional Minkowskian space-time geometry represents the time experienced by this moving reference frame. This negative metric signature occurs because it is the metric of time and space that change with inertial motion relative to a fixed observer, and not the observed speed of light. By transitioning from section to section, we will demonstrate that the geometric letter sequences of the Genesis text describe the space-time geometry of special relativity in the four dimensions of space and time. Here we show all the elements of the first 14-letter algorithm laid out on three 5-dimensional space-time force spheres. Remember that the triangles and spheres are not in proper proportion, and in theory these spheres illustrate the case of special relativity where gravitational effects are not significant. Consequently, the underlying assumption is that the surfaces are still spherical, so that the letter geometry is still valid, but the spheres are so huge that the surface geometry behaves like a flat space-time in which the Pythagorean theorem holds true. Since the operation signs, such as the plus and minus symbols, are not encoded in this geometric system, we are free to place them at will anywhere in the letter symbol sequences. Some would argue that such freedom gives us too much license to fabricate meaningful statements, but in fact changing the operation signs or their position frequently generates new meaningful equations and algorithms. Here, for example, we show on the left the Minkowskian spacetime geometry, which takes the form of distance traveled squared plus moving reference time squared is equal to stationary reference time squared. In this case, the Resh Aleph to the Shin symbol represents the distance the moving frame has moved in relation to the stationary reference. But on the right, we orient our force sphere and space-time manifold differently, and the Beit Resh Aleph anchors a grid box that is oriented towards the future instead of the past. Using our stationary Shin as a reference, we can now plot any inertial Shin spatial frame in the grid mesh box so that the Resh Aleph to Shin segment represents that Shin's proper time. The Shin to Yud Tav segment now represents the distance a Yud photon moves in relation to any Shin reference frame. Since the speed of light is the same for every moving reference frame, and since the Shin frame time component of the light cone is always equal to the space or distance component of its photon, both being equal to the speed of light multiplied by the reference frame's proper time, we are left with a curious situation in which the proper time length for a photon is always 0. Or in other words, a photon which travels at the speed of light experiences no passing time. If a watch were strapped to a photon, it would never tick. Since the totality of a propagating light sphere and the light cone it generates is universally invariant, how does one account for the different sized light spheres that seem to arise from inertially moving reference frames moving at different speeds in relation to a fixed and stationary observer? The solution to this puzzle is somewhat counterintuitive, but diagrammatically illustrated on the right side of this slide. The answer is that the light cone is indeed invariant, but that different inertially moving reference frames not only experience the passing of time differently, but also cannot agree on what now is. In other words, space-time is a four-dimensional block or continuum, and different reference frames will have their spatial sections oriented differently when cut into sections along their proper time axis. And as illustrated here, the light sphere, although looking quite normal to the moving frame, will in reference to another stationary frame appear to be a different conical section through our universally invariant light cone. And although the top light sphere and light cone look bigger in the diagram, in fact, relative to the stationary reference frame below, it is an earlier or past section of the light cone and a smaller light sphere. This analysis is based on the calculation that results from the Minkowskian analysis represented by the triangle on the left side of the slide. I would like to introduce one more concept before closing this introductory presentation. This concept will be more fully analyzed in a later presentation. In the last few slides, we presented the geometric structure of light cones and the analysis of inertially moving frames of reference in the special case of flat spacetimes. In flat spacetime, gravitational effects are negligible, and gravitationally induced spacetime curvature is minimal. In such a case, we assumed that our triangles were drawn on spheres of immense size, spheres whose radius approach infinite length. Now I would like to consider the opposite scenario. In this geometric paradigm, our sphere is of finite radius, but our triangle is very small, and in fact, the triangle becomes so small that it approaches infinitesimal size, or in other words, it shrinks to the smallest possible size before disappearing into a dimensionless point. Here we see a sphere with a fixed stationary origin at the base Resh Aleph position. The Beit Resh Aleph construction represents the intersection of two perpendicular great circle geodesic curves. One Resh curve represents time, and the second Resh curve plots distance. In this case, we model a distance Shin spatial reference frame in free fall motion towards a mass moving along its timeline geodesic starting at Beit Resh Aleph. Both geodesic paths are shown starting from the spatial Resh curve representing the equator of the sphere, and both geodesics converge over time at the pole. The triangle that we construct here also represents a light cone, but unlike the light cones presented in the previous slides, which were outgoing or future light cones, this light cone represents the signals approaching the free-falling Shin reference and are therefore inverted and represent a past light cone of incoming information. This five-dimensional sphere with two Resh geodesic curves that converge over a spherical surface of space and time is a geometric expression of gravity and free-fall acceleration but it is certainly not the way in which we conventionally encounter gravity in our common day experiences. Here we have a more familiar presentation of the phenomena of gravity using the more conventional Galileo dropping a weight from the Tower of Pisa type of model. An object labeled shin F for free fall is dropped from a tower towards an observer standing on the Earth's surface below, who is labeled shin S, the surface of Earth. But shin S stands on the Earth's surface, which is approximately 4,000 miles away from the Earth's center of gravity, where we can mathematically assume all its mass is located, and which we can label shin M for mass. A falling body will experience accelerating motion towards the ground, and if we plot this path in time, we get a parabolic path as illustrated in this slide. When we think of gravity, it is this falling body that we usually think about. But Einstein had a revealing insight. He realized that it was the object or observer standing motionless within the gravitational field that felt the force of gravity. In this case, the observer standing on the top of the tower, or the observer on the surface of the Earth, feel the force of the Earth pushing up against their feet. In contrast, the object in free fall feels no forces exerted on it. Einstein realized that the force pushing up against these observers was an accelerating force that essentially kept them in the same position relative to the Earth's center of gravity. They were being accelerated away from the center of Earth, yet standing motionless. Since standing motionless in a gravitational field was equivalent to undergoing acceleration in a region of space with no gravity, this principle was called the equivalence principle. But if the object in free fall was experiencing no force, then it must be in an inertial state. Even though the object was in an inertial state, free of forces, Einstein assumed that it was in a state of accelerating motion because it was simply following a straight line path through space and time. But to accelerate towards the Earth while moving in a straight line path meant that the straight line was moving over a spherical surface, and that the gravitational field generated by the mass at the center of the Earth was curving space and time into a large sphere. Gravity was telling space and time how to bend, but space and time was telling the object how to move. The greater the mass, the greater the curvature, the smaller the sphere, and the faster the geodesics will converge towards the pole. The model presented here illustrates the free-fall path for an object moving on a space-time manifold at some distance from the center of gravity. We illustrate the curved geodesics of the gravitating mass and the free-fall object for two different gravitating masses producing two different spherical space-time curvatures. The free-fall path is here analyzed in both cases for a duration of space-time that is equivalent to the time it takes for a light signal to travel from the center of gravity to the surface. We now have three line segments to complete the construction of a right triangle. A line segment from the aleph to the shin represents the distance from the center of gravity to the free fall reference system. The shin to yud segment represents the shin free fall path or world line that moves through space-time from its starting position at some height to the ground, where its world line intersects with a theoretical light signal from the center of gravity. This light signal from the aleph to the yud position is the third segment of this right triangle and represents its hypotenuse, thereby completing our right triangle and conforming to the letter sequence of the Genesis text. The equation in this case takes the following form: the square of the spatial distance minus the moving frame time interval squared is equal to the square of the invariant space-time interval, which in this case is a light-like interval and equal to 0. but more on this in a future lecture dedicated to the special theory of relativity. For now, it is the general theory of relativity that we are interested in, and this theory attributes the strength of a gravitational field to the local space-time curvature produced by a mass at a distant origin location. The metrical ground form analysis is the measure of this space-time curvature, and it is accomplished by taking the triangle we constructed earlier and overlaying it on the Gaussian grid system that we constructed earlier using the geometric letter sequence from the next sequence of letters in the first passage, the Haaretz Hayta Tohu Vavohu. In the next slide, we will illustrate the application of this procedure to a specific example. And in this slide, we illustrate the measurements that are obtained for the metric ground form analysis of an object falling in the Earth's gravitational field at the Earth's surface. For a gravitational sphere that represents the space-time curvature at the Earth's surface, a theoretical light signal would travel approximately 4,000 miles over approximately 1/50th of a second. The time segment is converted to a space-time distance of the same length of 4,000 miles, and over 1/50th of a second, an object would fall approximately 1/10 of an inch. In other words, this right triangle deviates from a perfect Euclidean right triangle by only 1/10 of an inch over a distance of 4,000 miles, and these values essentially represent the curvature of space-time at the Earth's surface. The mathematical formulation of this geometric theory of gravitation is the general theory of relativity, and it is this mathematical formulation expressed as an idealized spherically curved manifold in 2 dimensions of space and time that is mathematically constructed in the geometric translation of the first 11 words of the Genesis text. A full analysis of this compact and elegant formulation of gravitation will be provided in our 3rd presentation. Meanwhile, all the pieces necessary to solve this part of the Genesis puzzle are provided in this video and on the slides presented on this website. The key to discovering this geometric formulation is to construct a Gaussian grid system on the surface of the gravitational space-time sphere and apply a metrical ground form analysis at some fixed distance where the force of gravity is being analyzed. The application of the metrical ground form analysis to a small mesh region of this Gaussian grid involves the construction of a small right triangle that approaches infinitesimal smallness, as is illustrated in this slide. See if you can put the pieces together and solve this component of the Genesis puzzle as I continue to explore and reveal the secrets openly hidden in the most incredible passage of text ever written.